So this is a continuation that we are going to have from the previous case that we had, the introduction, where we talked about all the theorems, the properties of your shapes, the properties of parallel lines. So on this exercise, which is exercise 1, we are given A in the diagram, ABCG is parallel to FD. So this line ABCG is parallel to FD, as we can see from the diagram. And also ABCG is perpendicular to GH. This time, this line that you are seeing and this line of GH, they are perpendicular, meaning to say they meet at 90 degrees. Also, another part that you're not given there is this part of the BF and also the line of the CD. They are also parallel. So you have to consider everything about the parallel lines. Everything that you know about your parallel lines. So given the angles that that is the angle BF, E200, and also CGD, which is 50 degrees from our diagram, we can see this is our reflex angle, which is this one of 200 degrees. And also we are given this angle CGD, which is 50 degrees. This is the one that we are given here. All right. But remember, previously that we are given that the whole of this angle is 90 degrees. They are perpendicular, meaning that the whole of this angle is 90 degrees. All right, so let us consider what we are given. So the question is, calculate the size of all angles indicated by small letters. So we need all these angles that are indicated by the small letters. All right. Let us consider what we have. All right, let's start with the point where A is. This is the first part. All right. Let's consider where this A is. There we are given this angle as A, and also we are given this as 2A minus 50. And this is 200 degrees. What do we know? We know that angles at a point which is considering a complete revolution like this, a complete revolution like this, it must give us 360 degrees. So meaning if I take this A and also this angle of 2A, okay, we'll take this A plus the 2A minus 50 degrees that you're given, and also the 200 degrees that we have. All these angles that we see on this point, everything here, it's a complete revolution. It must give us 360 degrees. So there we took this from a complete revolution. All right. So meaning to say, this is now an equation, because all this in terms of A must be equal to 360. So you're just going to solve, remember, your linear equations. This is same as 1A. If the number is not indicated, if the number is invisible, that's a 1. So 1 plus 2, that is going to give us 3A. Then you combine the numbers together, minus 50 plus 200. So you're going to combine this. That is going to give you 150 degrees, which is equal to 360 degrees. So that means 3A is equal to, you can transpose the 150 on the other hand, which is on the other side of the equation. It was a positive. So what happens if you transpose it? It changes this sign that you're given. All right. So the moment that you take a positive, this side, it changes the side the moment that it crosses the equal sign. So it's going to be minus 150 degrees on this side. All right. So if we were to subtract 360 minus 150 degrees, what were you going to have is 210 degrees. So to determine A, or to find A, this is a product. So how do you remove this 3 that is multiplying? You divide by 3, since this is a product. So as you can see, you are now solving an equation. Just like 2x is equal to 10. How do you find x? You divide by 2 by 2. It's the same thing. So you're going to divide by 3. So A is going to be 210 divided by 3, and that was going to give us 70 degrees. So meaning to say we could have taken that into consideration, that a complete revolution is 360 degrees. So we can use that as an equation. So this is our A, which is 70 degrees, this part of A. All right. Which other angle that we can determine? This is up to you how you want to determine. You can also find B, because these two lines are parallel. Remember, from our alternate angles, if we form a Z, if we check here what is happening at B there, I want you to see this. You're going to form something like this. That's this way. So meaning to say this B and this 70 are the same. We are forming a Z, the Z concept, alternate angles. So meaning to say B is equal to what? To 70 degrees. So B is equal to 70 degrees. Also, it is alternate to what? To A. B and A are alternate angles. In the same sense, you can find, after finding this, you can find C, because you check B and C, what is the relationship? If two straight lines intersect like this, these are called vertically opposite angles. Vertically opposite angles. So meaning to say vertically opposite angles are equal. Remember that. So if this is 70, this is also 70 degrees. So C was equal to 70 degrees from vertically opposite angles. Vertically opposite angles. All right. Let us move on to another part from C. Let's check where D is. Okay, D, we can find this D. If you are to consider these two lines, they are parallel. Okay, and if you check what is happening, we are forming a C. Okay, if you take this into consideration like this, you come back this side, you come back like this. There is something that we had about these angles which form a C like that. These are called co-interior angles, and co-interior angles are supplementary. Co-interior angles are supplementary. So meaning to say that this angle at A and the angle at D, they add up to 180. They are supplementary. A plus D is supposed to give us what? Is supposed to give us 180 degrees. But remember, we calculated A, it's 70 degrees. So meaning to say we can have D. If we take this 70 to the other side, it's going to be a minus there. So D, it's 180 minus 70 degrees, which is going to be 110 degrees. So we took this one from co-interior. Co-interior angles are supplementary. Co-interior angles are supplementary. They add up to 180 degrees. So meaning to say, if you add this 70 at A and this 110, you get what? 180 degrees. That is the supplementary part, two angles. Okay? If you do the same thing, because these two lines are also parallel, you are going to see that it is also happening on E. This angle E that we are having here and this angle D that we have, they are also co-interior. Look here, we are forming a U, a C, something like this, a U shape. So this and this, they add up to 180. So meaning to say, in the same manner or in the same sense, we can calculate angle E, because angle D plus angle E was supposed to give us 180 degrees. And in this manner, we saw that we calculated this and we got 110. So 110 plus E is equal to 180. We solve this transpose or take it this to the other side of the equation. 110 on this side, it will be a minus 110. So 180 minus 110 is 70 degrees. So this is going to be 70 degrees. So E is equal to 70 degrees. So that is how we could have calculated our E. All right, let's check another part. Can we calculate F at this moment? Is it possible to calculate F at this moment? All right, so we can consider this part. All right, we can consider this. It was just something that is a little bit hidden, but I want you to see what is happening here. Remember, I talked about the issue of the exterior angle of a triangle, all right? So let me do this so that you understand that theorem. I talked about that. If you consider this from B to C to G like this, all right, if you join this triangle like this, all right, this line that we have drawn, G, this one, GCB, it's a straight line, as you can see. It is forming this angle of 70 degrees outside of this triangle CGD. This angle 70 is outside, so it is called an exterior angle. Remember what I said about the exterior angle of a triangle. If you're given a triangle like this exterior angle that is outside is equal to the sum of these two opposite interior angles. So if it is like that, it means the 70 degrees that we are seeing here, it is equal to the sum of this 50 and this F. It means, guys, it means this. If it means 70 is equal to the sum of this 50 degrees and this F. So it's an equation. You can solve for F, transpose this. It will be 70 minus 50 degrees is equal to F, because of this exterior angle is equal to the what? The sum of two opposite interior angle. So F was going to be 70 minus 50, which is 20 degrees. Okay, maybe you do not want to use this. You could have calculated the same way, the same F this way. All right, another way to calculate F. All right, let me just put it this way. You could have calculated this. You could have calculated first angle GCD or DCG, this angle here. Why or how can we calculate this angle DCG? This angle lies on a straight line together with these 70 degrees. And we know that angles on a straight line add up to 180. So it is going to be 180 degrees minus 70 degrees, which is 110 degrees. We took this from angles on a straight line. Angles on a straight line. Angles on a straight line add up to 180 degrees. So we can calculate this angle this DCG, which we calculated now. This is 110 degrees, 110 degrees. Okay, so how can we calculate angle F now? CDG is a triangle, and we know that angles in a triangle add up to 180 degrees. So therefore, our angle F will be 180 degrees minus these two angles inside of the triangle. We are now using the concept of angles inside what? A triangle, if you want to use that. So it will be 110 degrees plus 50 degrees. So this will be 180 degrees minus 110 plus 50, that's 160 degrees, which is equal to 20 degrees, which is the same as this one. There are so many ways. This is Euclidean geometry. As long it is a proven fact, use that. As long it is a proven fact, you are supposed to use that. As long you are working with what? With a proven fact. Is it a proven fact that you are using? Is it a theorem? That's what I'm trying to say. A proven fact is a theorem. Is it from a theorem? If it is not from a theorem, then it means we can't use this. We can't use that. All right, so I hope you are following. So that is our angle F is 20 degrees. Let me just indicate. So I'm just going to erase some of these guys. I hope now you have seen where we have taken this. So this is 20 degrees. Okay, let me just erase because we have these angles on the diagram. So there's no need for us to worry. Let us move on to another angle that we can calculate. We can calculate angle G. All right, how can we calculate angle G? Angle G, remember we were told before about this, all right, being perpendicular, that's a 90 degrees there. And of this 90 degrees that we are given, there is a 50 degrees there, which is CGD. So meaning to say, to find angle G, we are going to simply subtract 90 minus this 50, because these two angles, this G and this 50, they add up to what? To 90 degrees. So to find G, I simply subtract 50 from 90. That is what? 40 degrees. So our G was going to be 40. So that 50 plus 40 is 90 degrees. Just like that. All right. What about the other part? Remember, we are also given this indication shows that these two lines are equal. From D to G, from D to H, they are equal. Remember what I said? If the two lines are equal, it follows that opposite angles also must be equal. From those lines, what are the opposite? This one is opposite to what? To H. This one is opposite to G. So it means by default, angle H is equal to 40 degrees. So if, I mean, this angle H, this one, not this one, not this H here, but this H from GHD. Let's just write it this way. GHD is equal to what? 40 degrees. That is angles, all right, opposite angles, opposite equal sides. Opposite equal sides, they will be equal. So if this is 40 degrees, it allows us now to calculate this small letter h. Remember, us, we need the letter h. So h, using angles in a triangle, it is going to be 180 degrees minus the angles that are inside of the triangle, the 40 and the 40. So h was going to be 180 degrees minus 40 plus 40, that is 80 degrees, and h is going to be 100 degrees. So this angle h at this point is 100 degrees. All right. So with angle h, how can we determine angle I, this one, which is I, this I that is remaining? All right, I want you to see, don't be confused. I is this part, not there's another part that is remaining there. So we can use the concept of a straight line like this. This is a straight line like this. So we know that angles which are found on a straight line must add up to 180 degrees. So using that consideration, or using that advantage of angles on a straight line, adding up to 180, it means if I add F, if I add to H, if I add with I, am supposed to obtain 180 degrees. We have our angle F. Remember, we calculated our angle F is 20 degrees. So 20 degrees plus angle H, we calculated H, it's 100 degrees. We want to calculate angle I this time, so we can form an equation. Okay, so this is 120. If we add this, plus I is equal to 180. So take this to the other hand. 180 minus 120. This was a positive this side, so it will be minus 120 on the other side. So this was going to give us 60 degrees. So that is our angle I. On the other hand is 60 degrees, which is this part of our diagram. That is where our I is, which is 60 degrees. All right, is there any angle that we left? No, we calculated all the lettered angles from A, B, C, D, everything. We have reasons reasons are theorems that we talk about, angles on a straight line, this and that. Then show that DF is perpendicular to FE. DF, where is our DF? Okay, let's see from our diagram, our DF, guys, very sorry for this, okay. All right, very sorry for that. DF. From D, this is our D here. Okay, this one D here. This was our D here. All right, there's a 60 there, but this is our D. So they are saying this DF, this line, all right, is perpendicular to FE. This is FE. All right. So if these two lines are perpendicular, it means we must have a 90 degrees here at what? At FAE, at DFE must be 90 degrees. So let's prove that. All right. So we want to prove that. So how can we prove that D, in fact, to show that? All right, we need to just to show that. So this question, you simply, if you are given that DF is perpendicular to FE, you need to show that DFE, this angle, DFE, this angle. All right, DFE is equal to 90 degrees. So you are supposed to show that. So how can we show that? Okay, let's calculate this. DFE is equal to what? DFE is equal to 2A minus 50 degrees. So this is it. We have A, we calculated our A before and we said A is 70 degrees. So let's just substitute 2 times A, 2 times 70 degrees minus 50 degrees. So 2 times 70, that is 140 degrees minus 50 degrees. And that is going to give us 90 degrees. So this one was going to give us 90 degrees. So therefore, if this angle is 90 degrees, what does it mean? It means DF is perpendicular to what? Is perpendicular to FE. That is what it means. So that was the idea of our question. So guys, be careful how you answer your questions. You have to be careful. You're going to have a continuation of this exercise and also try to work with your question papers as well. Remember, I said it is very, very important that you do work with question papers as well.